we're looking at our series and parallel circuits. Okay, the formula that we want to verify is the following: 1 over RT for parallel, and RT is equal to the sum of the other resistors, isn't it? Alright, we know that our formula for V is the following. So we want to work out what our current is, because really what we're trying to do here is find our I, which we are measuring, and then we want to compare that to our I, which we're going to calculate, because you've got measurements of all of that stuff. Alright, now to do the calculation, it's pretty simple. To work out what your resistance is, it's really important to do that. So in terms of, let's say I had 1,000 ohms, so RT for the series is going to be 1,000 plus 1,000 plus 1,000, and so that's obviously equal to 3,000. If I want to work out what my voltage is, my current, I is equal to V over R. So in this particular case, if my voltage is, say, something like 4 volts, 4 divided by 3,000, and that will tell you what your result is. So someone do that in the calculator for us really quickly. 4 divided by 3,000. Yeah, 750, so it's what's going on here? 0.0133. So if you times that by 1,000, that will get you to milliamps. Okay, so that is actually equal to 1.33 milliamps. Alright, now by now you should know how to do fractions. Okay, if I wanted to do my parallel circuit, alright, my parallel circuit is simply going to be 1 over RT is equal to 1 over 1,000 plus 1 over 1,000 plus 1 over 1,000. So that's equal to, well, you can just put that into your calculator as you see it, alright, and then that will give you 3 on 1,000. That's what it's going to give you. So that's what my 1 on RT is. So therefore, RT is equal to 1,000 divided by 3. Now if you do it on your calculator, what you're going to need to use, what your answer you get from doing this, at that stage there, you're going to use your x to the minus 1 button, or what you'll do is you'll go 1 divided by your answer, and that will give you the answer over here. So that's going to be, if you're looking at that answer here, that is 330.33 ohms. So therefore my current over here is going to be what? It's going to be my voltage, which is, say, 4 divided by 333.33, and that will give you a current of, someone do it on the calculator for us, 0.0012. So that there is 12 milliamps, what we're looking at there. Alright, so now the question is, if you're doing this calculation, Jones, you need to pay attention, mate. If you do this calculation, it's going to be repetitive, isn't it? So why don't we use our calculator to do that for us? Or not a calculator, but use Excel. So I'm going to show you how to do this on Excel, the same thing I've just done there. I'll blow this up so you can see it. So let's say we've got 3 resistors of 1,000. Then for my series circuit, my total resistance is going to be equal to that cell there plus that cell there plus that cell there. Alright, just putting in a formula, isn't it? That's what we had. Now, my resistance 1 over RT, right, is going to be 1 equals 1 divided by 1 divided by that plus 1 divided by that plus 1 divided by that. Enter. It gives me my answer. Alright, can you all see that? Yep. Alright, so they are these are my my particular values. Alright, so they're my total resistance that I'm going to use for my calculations. Alright, so let's say we had our measured. Alright, so our measured thing over here was for, this is the series one, so it's equal to 1.3 milliamps. Okay, that one there was 1.6 milliamps. This is where you put your results in there. That was 1 milliamp, and that's 1.9 milliamps. Okay, so you're just going to enter those values into that part of the table. Now, the next thing is we want to calculate what our current's going to be, don't we? In here, we've got our voltages that we measured using our ammeters. All right, so not our voltmeters. So over here, to work out my current's simply going to be equal to my voltage divided by this is a series circuit. It's going to be my series value. Now, we always want to read that value, don't we, in terms of this formula? So to do that, do you remember how to do that in Excel? You press F4, and what it does, it put dollar signs around it. Okay, and so then what all I have to do here is just drag that down, and it actually does all those calculations for me. So then it goes C5 divided by B8, C6 divided by B8, and so on. Now, I'll do the same thing over here for my calculated one over here. Equals, alright, so for my series, for my parallel circuit, that's going to be equal to my voltage. So scroll across, get your voltage, divide that by my resistance for my parallel circuit, which is that cell there. And again, if we use our dollar sign, that will fix it to read that cell all the time. Enter, and I can just fill that down. Now, to do our percentage error, what is it? Well, what's the correct value that we're looking for? What's the correct value? A theoretical value. The theoretical value is the calculated value. So that's got to be the one that we assume is correct. The measured one is the one that's going to vary due to the prac. So, if we've got, let's just do the series one. I might do the other one. So we've got these two values here. We've got our measured current and we've got our calculated current. Alright, now these of course aren't in the right units, are they? What are they measured in? They're measured in amps. So what I could do here, if I times that by 1,000, they'll now be in milliamps, won't they? Alright, so again, if I use my fill down, I can then go, alright. So the difference when you're doing your percentage error should be equal to the difference between the two values. Now, one little thing that you use in maths, which you don't really need to know about, but if you use a thing called the modulus or absolute value, you'll find the difference between two values and always display it as a positive answer. Right? So if we use absolute, so we start typing absolute, that's the absolute value. Alright? And what we want to do is we want to find the difference between the measured and the calculated value. So let's do the calculated value, take away our measured value, bracket, and then we divide that by our calculated value because that's our expected value, and then we times that by 100 to get it to a percentage. Okay, and then once I've done it once, guys, you paying attention over there? Once I've done it once, then all I have to do is fill it down and it will find out my percentage errors for all the other ones as well. Now, the good thing about this, if I just reduce this in size, in terms of my spreadsheet, right, so that's my first one for one of my circuits where my resistor 1, resistor 2, resistor 3 is there. What I can do now is I can just copy all of that. How many do I have to do this for? So I can go here, paste, and then go down over here and paste. Now, the good thing about this is, if I change my resistors, so let's say my next lot of resistors were 470, 470, 470. Okay, now the only thing is, what you will have to change here, guys, when we're starting to look at our calculator thing over here, you're going to have to change that value to be that cell there and F4 it, because that won't automatically change, because remember we're fixing it to be that cell all the time. So when you copy it, it doesn't change that. So you need to fix that up there, and you have to do the same thing with well, sorry, that was a series, wasn't it? So for the series one, I need to select the series resistance. Right? And once I've done that first one, and I do my dollar signs, then all I have to do is I need to fill that down. Okay, and I've got that down, and it's done. Right? So doing your calculations, because they're repetitive, all I need to see is one set of calculations which are done like full hand, and the rest of the time you can actually do the rest of them using Excel. It does make life a little bit easier if you use Excel, because, you know, certainly if you understand, but you have to actually understand what the calculations are about and what you're doing with that, right? And that will make your life easy. Now, considering it's a prac writer, right, we need to have a very short aim. Right, what the aim of the prac was to do what? Yeah, we're basically proving those resistance laws, weren't we? Okay, we're proving the resistance laws by comparing the measured current with the calculated current. That's what we're trying to do. You should have a hypothesis, which is an educated guess. You need to go through your experimental setup, right? The steps what you did. You need to supply your data in a table, like I've just shown you here. You need to obviously analyse your results, the sort of results that you did get and why you might have got them. And then you obviously need to be talking about systematic errors and random errors. You need to identify your independent, dependent variables. That's really important that you're doing that. And then you'll need to have some sort of conclusion where you tie it all together whether we proved our aim. Alright, so that's what we need you guys to be working on. Now the due date for that will be the 27th. Alright, so